Okay, so a fairly short exercise today looking at powers. So we need to understand our squares, our square roots, our cubes and our cube roots, as these come up for a lot in both the algebra and the number section of the GCSE. So the first thing to understand is a square number, which is made by multiplying a number by itself. It's helpful just to realise why they're called square numbers. If I arrange here a group of dots, so let's say I've got 1, 2, 3 dots. If I do 3 dots going downwards to make it into a square, and I'm just going to fill in the dots, that is a square. It's 3 dots wide, 3 dots across, which is 9. And that's why 9 is called a square number. So a square number is made by multiplying a number by itself. So for example, 3 times 3 would give you 9. A times A is called A squared. Cube numbers are exactly the same, but rather than multiplying it by itself once, you're multiplying by itself again, so it's times by itself 3 times. So for example, you'd have 3 times 3 times 3. We've got our 9, which was 3 times 3, times by 3 again, would have given you 27. And you would write that as A cubed. And this number tells you how many times you multiply the base by itself. This is your power, this is your base. The power tells you how many times you multiply the base by itself. Now, the opposite, or the inverse, to use a more mathematically correct word, of squaring something is finding its square root, which is almost like a division sign. It's not quite. Notice this is at an angle rather than flat, and it's got this little tick at the end. So the opposite of squaring something is square root. You could, but you don't always see a 2 there to tell you it's the square root. If there's no 2 there, if there's no number, then it's automatically the square root. The opposite of cubing is the cube root, and here you would always see the number 3 if it was telling you it's the cube root. So we're going to do a couple of worked examples here. So let's have a look. Firstly, nice and simple, 3 squared. Well, this power tells us how many times to multiply the base by itself. So this tells me I multiply this number by itself twice. 3 times 3 gives me an answer of 9. Okay, be careful. It's a really common mistake when we're not thinking. We know that this isn't right, but the common mistake is to say, oh, that means 3 times 2, which is 6. It's not what it means. It means times 3 by itself twice. So let's have a look at the next one, and we need to be quite careful here. And especially this is a really important bit for calculator usage, -5 squared. So this is telling me that I multiply my base by itself twice. So I'm just going to write it out in full. That means -5 times -5. And a reminder that when we've got a negative times a negative, our answer there is going to be positive. So we get an answer of positive 5 times 5, which is 25. Now, I'm just going to demonstrate to you why you need to be really careful here when using a calculator. What I've typed into my calculator is the negative button followed by 5 squared, and that's giving me an answer of -25. Now, the reason why it's doing it is working out 5 squared, which was 25, and then making it negative. If I'm ever squaring a button on a calculator, I need to put it into brackets. As you can see now, when I put the -5 into brackets and I'm multiplying -5 by itself, it gives me the answer that I was expecting, which is positive 25. So be really careful in using brackets on this. Okay, we're going to have a look now at what happens when we've got a negative number cubed. So remember that this 3 tells me I need to multiply -2 by itself 3 times. So this means -2 times by -2 times by -2. Now, I can't do that all in one go. So what I'm going to do, I'm going to do this bit first. -2 times by -2. Well, we already know that negative times a negative gives me a positive. So -2 times -2 gives me positive 4. That's a positive 4. And I'm going to multiply that by -2. I've now got positive times by a negative, so it's going to give me a negative answer, and it's going to give me the answer of -8. So this is really important for us to understand. When we've got a negative number and we square it, it becomes positive. When we've got a negative number and we cube it, it remains as a negative number. And if we want to go even further, but this is beyond the scope of the Foundation GCSE, if this power is an odd number, then you're going to end up with a negative answer. If the power is an even number, you end up with a positive answer. We're now going to look at the last bit, which is looking at squaring decimal numbers. So here I've got 0.4 times by 0.4. Now, taking us back a couple of lessons, we need to count the number of decimal places. 1, 2. So I'm going to put in my decimal places. 1, 2 decimal places. I know that 4 times 4 is 16, so I fill it in from the right. 16. And it gives me an answer of 0.16. Okay, can you pause the video there while you take down the worked examples, and then we're going to give you some questions to try. Okay, so there's 11 questions for you to try on this bit. For the first 2, I've asked you to write out the first 10 squares and the first 5 cube numbers. Those are really important for you to know. You do need to know them off the top of your head. So I'm just going to start this one off for you. So here you'd get 1 times 1 times 1, which is 1. 2 times 2, which is 4. 3 times 3, which is 9. Okay? I want you to finish that, and we should get up to 100 is the last number in the list. For the cube numbers, you've got 1 times 1 times 1, which is 1. 2 times 2 times 2, which is 8. So my list starts with 1, followed by 8, and I want you to get up to the last one, which is 5 times 5 times 5, which is 125. I'll let you fill in the gaps. 3, 4 and 5 are just simply squaring some numbers. Cube root of 1000, that's asking you what number times itself 3 times would give you 1000. Question 7 and 8, asking you to use your understanding of negative numbers. Again here we've got a decimal, again here a decimal. Question 11, bit more difficult, what number times itself 5 times would give you an answer of 32. Okay, I'm going to let you pause now, have a go at these questions, and then we'll come back and we'll mark them. Okay, so we're going to go through our solutions now. So the first one was the first 10 square numbers. These ones in red were the ones which were missing. You do need to know this list off the top of your head. You do need to know that all of these are the first 10 square numbers. Similarly with your cube numbers, 1 times 1 times 1 was 1, so 2 times 2 times 2 was 8, 3 times 3 times 3 was 27, 4 times 4 times 4 was 64, 5 times 5 times 5 is 125. Okay, we're starting to go on now looking at square numbers. So 0.5 squared means 0.5 times 0.5. That's going to give me 2 decimal places, gives me 0.25. 14 squared, you just need to do a long multiplication here. 14 times 14 is 196. 300 squared, well, I'm going to do 3 times 3, which is 9, and then I've got 1, 2, 3, 4, 0, so it gives you 90,000. Cube root of 1000, well, it's asking what number times itself 3 times gives you 1000. 10 times 10 times 10 gives you 1000, so your answer is 10. Question 7, you've got negative times negative, gives you an answer of positive 9. You don't need to have the plus in front, but just to make sure it's clear that that's a positive answer. Negative 2 cubed, negative 2 times negative 2 would give you positive 4, times by negative 2 gives you negative 8. Starting to get quite difficult in questions 9, 10 and 11. Here we've got 0.2 cubed, we've got 1, 2, 3 decimal places, so 1, 2, 3 decimal places in our answer. 2 times 2 times 2 is 8, but it's going to be 0.008. Similarly, we've got 4 decimal places in the question here, 1, 2, 3, 4. 12 times 12 is 144, so 144 goes in here. 0.0144. Last one here, asking what number times itself 5 times gives you 32. Well, it's going to be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Let me just put in that 2. So the fifth root of 32 must give me 2. Can you give yourself a mark, please, out of 11? For those of you who need some extra help on this, please go on to Hegarty clip number 101. Well done.